Today we are talking about the printed circuit for an Arduino ESP32 project. I should have done this much earlier because it's worth it. I thought it would take a lot of money and effort to design and make a printed circuit board. But that's not true actually. Today I will explain my PCB for a slot car lap counter project. I will also show you the important steps and the effort involved in designing with KiCAD using that practical example. When you realize a new electronics project, you are usually starting with the critical parts of the circuit on a breadboard. You are developing the code for it and you are testing the main functions. In the next step, you're putting the entire circuit on a universal PCB and connecting all the sensors, LEDs, etc. That allows you testing under real conditions. I love projects where I can implement my own ideas for additional features and improvements. Of course, I need to further develop the hardware and the code accordingly. However, in the end, the circuit becomes more and more confusing. And at some point I always realized that I should have been better started earlier designing a PCB for the project. I chose KiCAD because it is a great freeware tool that runs on all operating systems. There is certainly a hurdle to overcome if you have no experience in this field. I have a bit of experience and it took me about a day and 5 YouTube tutorials to understand the important features of the program. After playing with the tool another day, I was able to design relatively complex PCBs myself. It would be worse using the tool just to create a circuit diagram, which can be easily created and managed. It might take some time to find the right symbols in the comprehensive database, but after that you're making quick progress. We assign the footprint to the first of every circuit element, so that we can easily build the entire circuit using copy and paste. By the way, I'm always saving the circuit diagram as PDF file in black and white. Here we have the ESP32 development board with integrated USB interface and Wi-Fi antenna. I'm using a separate output for each pair of LEDs so that we can change the start sequence of our start light later in the code if we want to do so. At the bottom left we have the adjustable voltage dividers for measuring analog voltages from the tracks. I added 4 Schottky diodes that protect the 2 analog inputs from overvoltage and incorrect polarity. Here we have 2 stabilization capacitors and a series resistor for the buzzer, which was too loud for my taste. The resistor is reducing the loudness and it also limits the current that could possibly overload a digital output of the processor. And then we have 2 connection strips for the peripherals. The program takes all elements and connections from the schematic into the PCB Editor. Even when KiCAD gives support, it takes some time to place the elements and then draw the conductor tracks according to the connections. By the way, the LEDs are on the back side of the board, all other components are placed on the front side. 2 copper layers are sufficient for my circuit. Of course, you have to define the outline of the circuit board and it also makes sense to add mounting holes. The labels for the components are also taken from the circuit diagram and you can add arbitrary text as label. I particularly like that I can add a logo. And the KiCAD package includes a good transformation program for that purpose. Just as a side note, you can also apply the bitmaps to realize a copper layer, allowing me to implement high-frequency circuits such as filters, antennas, etc. as a printed structure. So stay tuned, because things could even get more exciting on the channel. And then there is another very helpful feature in the PCB Editor. With the measuring ruler you can measure all dimensions precisely at any time. And this helped me a lot to determine the dimensions we needed for the casing. Here we have the connectors for analog voltages of the tracks, sensors and the push-button switches for the start-stop-reset control. On the other side we have the connectors for the buzzer and the relay board. The 3D viewer is really nice because it gives you a preview of what the electronics will look like later. The 3D models for the components are usually already included in the footprint. For the ESP32 development board I found a footprint but unfortunately no 3D model. I don't care, I simply copied a picture of the development board into it. Looks cool already. When we are satisfied with our layout, we use KiCAD to create the so-called Gerber files, in which everything for the professional PCB manufacturing process is stored. In order to exchange data, you have to compress the Gerber files into a zip file. Here are 3 tips before you send the Gerber files to a manufacturer. First, print out the circuit board in its original size on paper and check whether the components fit. Second, print the board larger and in black and white and check whether the conductor tracks correspond to your circuit diagram. I do this with colored markers, which may look a bit old-fashioned, but the method is effective. Third, KiCAD offers a Gerber viewer that allows you to view and check the files. We can see the outline of the entire board, the mounting holes, all the holes for the components, the soldering pads, the outlines of the components, by the way, at the front and back, and then of course the labels and the logo. This is impressive, but very easy to do, because the KiCAD program is practically creating that automatically. Once you have created the Gerber files, you're only one step away from your professional PCB. I will show you this now with PCBWay, the sponsor of this video. I upload the zipped Gerber files to my account, simply as explained here on the right. There are choices for materials and colors, for which I used the default values, because they are all okay for me. If you want to check whether your data has arrived correctly, then you can use PCBWay's preview function. The next step is to place your order with the usual information such as payment method, delivery address, etc. Then you can select the priority and shipping options and off we go. Cool, isn't it? Uploading the data and ordering was really no effort. And now I'm looking forward to my first professionally made printed circuit. KiCAD is really a very helpful tool. By the way, I'm using version 7.0.10. The training was a bit of a hurdle, but I should have started much sooner, and you can do it too. For me it was worth it, because I'm not only getting a professional layout for my electronics, but also a clean documentation. That goes well with electronics.unmasked, isn't it? Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.